Lesson 85 has two parts. The first part is on order of operations with signed numbers, and then the second part will be another lesson about functions. To understand order of operations with signed numbers, let's just go ahead and do some problems. You do your same steps on these like you do in all order of operations problems. Do your multiplication and division first, then do your addition and subtraction. And let's just go ahead and do that. Look at this problem. Work it left to right. We have a -4 plus a -4 times a -4, so that would be a positive 16. Then we have minus a -4 over a positive 4. That would give us a -1. So now we've got all of our multiplication and division taken care of. We can go back and add. Add in pairs. -4 plus a positive 16. That would give us a 12 minus a -1. And sometimes it's a good idea just to go ahead and put that minus a -1 in parentheses, put a plus sign in front of it to think about adding algebraically. And we remember what to do with a minus a negative, or the opposite of 1. That just equals a 1. So we say 12 plus 1 equals 13. That's our result. Good. Problem B. We have multiple symbols of inclusion on this problem, so we want to do the innermost set of parentheses first. And let's just go ahead and do that. -2 minus a -5. And do that multiplication first that's inside the symbols of inclusion. So we'd have minus -2 times -1 would be a positive 2, or just -2, like that. Now we go back and finish off our addition inside the brackets there. -2 minus a -5. Think of that as -5 plus a -2. And if you want to, you can even use a different colored pen like I did there and surround that -2 in parentheses, put a plus sign in front of it, and we have -5 plus a -2 is a -7. Okay, now we have -2 minus a -7, or again, just put all of this in parentheses, a plus sign in between, and we can see there we have the opposite of 7, which would give us -2 plus 7 equals 5. Key to doing these problems right, one important thing is to stay organized like we're doing here, and also just keep up with those signs. Anytime you have a subtraction in these order of operations, turn it into an addition problem by putting that symbol of inclusion and the number or numbers in front of it. I'm sorry, not put the symbol of inclusion, but put the sign and the number or numbers in front of it. Put that all in parentheses and then put a plus sign to the left of the parentheses. And that turns it into algebraic addition. That helps you because you already know how to do algebraic addition. You're thinking in those terms of adding negative numbers. So putting the negative and the number in parentheses like that helps you think of algebraic addition. Let's do one more order of operation problem. Work the innermost set of parentheses first. We have a -4 times a -3 minus a -6 times a -5. So really that's just saying -30. And then we'll have -4. And then do the addition there. -3 minus 30, or in other words, plus a -30. -3 plus a -30 is -33. Now all we have left is multiplication of -4 times -33, which would just turn out as a positive 132. These problems are a lot easier than they may seem as long as you stay organized and you keep up with your plus and minus signs. Just getting one sign wrong will make the whole problem incorrect. And isn't that the way it is in your everyday life too? If you're doing something and you do one thing wrong, then a lot of times it makes everything messed up. Apply your skills that you're learning in mathematics to your everyday life. Stay organized, be neat, be detailed in your work. You'll make fewer mistakes. You won't ever be perfect, but you can at least try to work towards perfection. God is the only one who's perfect. We were created in His image, the Bible says so, so that means we can get close to perfection, but we can't ever achieve it. That's only reserved for God. Let's go on to functions now, the second part of this lesson, and this is the second lesson that you've had on functions. The first lesson was back in lesson 58. Remember, functions, they're a relationship between a pair of numbers. You have an input value and an output value, and there's this function or this certain pattern that you have and that you follow to get your output value. For every input value, there's one and only one output value in a function. Here's another way that you might see a function. Remember, we said it's a relationship between a pair of values. So you could have an equation like this, y equals 2x plus 1, that has a pair of variables in it. And in a function, remember, you're given your input values, and then you figure out what the output is. Remember how I told you before, when we did these in lesson 58, how these are kind of like evaluate problems, and I had you create little formulas that related to the pattern that that particular function was trying to express. Well, here you've been given that formula, and like for this practice problem D, you've been given y equals 2x plus 1 as your function. All you do is evaluate that for those given values of x, and you can figure out what y is. So on the first one, we would just substitute 0 in for x, and we say 2 times 0 plus 1. 2 times 0 is 0, plus 1 would be a 1. Then for the next one, we would do 2 times 2 plus 1. And so that would be a 5. 4 plus 1 is 5. And the last one, we substitute a 5 in for x. 2 times 5 plus 1 is 11. For each input value or each x value, we have one and only one output or y value. 0 goes with 1, 2 goes with 5, 5 goes with 11. Let's do one more. Y equals 1/3 times x. That's our function, 1/3 x. We input those given values to figure out what the output or y values are. So for the first one, we input in -1. 1/3 times -1. We could say -1 over 1. We could put it over 1. And that would be -1 over 3, or minus 1/3. Then we have 0. 1/3 times 0 would just be 0. And then 1/3 times 3, hopefully you can figure out, that would just equal 1. The given values of x, those are the input values for the function. The function itself is 1/3 x, and the output is the y values. Here's something interesting that you can do with functions. You can think of those relationships, those pairs of numbers. Like look at practice problem D. You have 0, 1, 2, 5, 5, and 11. Think of those as coordinates and make an xy axis. What you can do is plot those coordinates or xy pairs on a coordinate system. So like the x and the y that are 0 and 1, you'd go 0, so that means you don't go to the left or the right any, just up 1, and you put a dot. Then you go to the right 2 and up 1, 2, 3, 4, 5. Put a dot. Then you go to the right 5 and up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You put a dot way up there. And do you see a pattern there? You can draw a line through those points and just continue it on, and that's the relationship. That's called graphing that function. We just graphed that function on an XY axis. That's a special thing that you can do with functions. They'll have some kind of pattern that they make on an XY axis or on a coordinate plane. You'll learn more about graphing functions later, but I just wanted to show you that's one, and that is probably one of the most important uses for functions. Functions are important in science. They're very important in engineering. They're important in computer programming. Functions have many important and good uses. Okay, well that's all for lesson 85.